Welcome back to Molecule. Today, we're going to talk about the one paper that, and I'm not exaggerating here, literally taught computers how to see. This is the paper that lit the fuse on the whole AI revolution that we're living through right now. So how on earth did they pull it off? Let's dive in. Okay, so take a look at this picture. You and I, we know that's a leopard, right? It's instant. Our brains just see it. We don't even have to think about it. But how do you get a computer, a box of wires and code, to do the same thing? How do you teach it that this is a leopard and not a cheetah or a jaguar or, just a really big house cat? Well, for a long, long time, the simple answer was they couldn't, not even close. Computers were just awful at it. Trying to get an AI to recognize objects in the real world with all its messy, unpredictable details, it was one of the biggest problems in computer science. And then, in 2012, this one paper comes out. And it didn't just move the goalposts, it blew up the entire stadium. So, to really understand just how big of a deal this was, you need to know where the showdown happened. It was this annual competition, the ImageNet challenge, but really everyone thought of it as the AI Olympics. It was the ultimate test for computer vision. And listen, this was no small-time event. The challenge was insane. You had a dataset with over 1.2 million images. And they weren't just cats and dogs. We're talking 1,000 different categories. Everything from like a container ship to a very specific kind of mushroom. The goal? Build an AI that could look at an image it's never seen before and tell you what it is. The team with the lowest error rate, well, they were the champions. This was the big leagues. All right, so into this massive competition steps our hero, a completely new kind of model. It was a deep convolutional neural network, and it was called ImageNet. And this thing, it wasn't just a clever algorithm. It was designed to work kind of like a new kind of digital brain. So what in the world is a convolutional neural network? Don't worry, it sounds more complicated than it is. The easiest way to think about it is that it's an AI model that's actually inspired by how our own brains see the world. It's built with all these different layers. The bottom layers learn to see really simple stuff, and then each layer passes its findings up to the next one to build a more and more complex picture. It's almost like how a baby learns to see, right? The very first layer might just learn to spot basic things, like an edge, or a corner, or a patch of a certain color. Then, the next layer up takes those simple things and learns to combine them into, say, textures like fur or basic shapes. Then that layer combines those to recognize parts of an object, like an ear or a nose or a tire. And then finally, the very top layer puts all those pieces together and goes, aha, that's a dog. Okay, so here's the thing. The basic idea of these networks, CNNs, it wasn't brand new. But nobody, and I mean nobody, had gotten one to work on this kind of massive scale before. So what was their secret sauce? Well, ImageNet basically had 3 superpowers that blew everyone else out of the water. All right, superpower number 1, the turbo button. They used this new kind of artificial neuron. The technical name is ReLU, but all you gotta know is that it let the network learn way faster, like up to 6 times faster than the old way of doing things. And without that speed boost, trying to train on 1 million+ images would have been basically impossible. Superpower number 2 was the rocket fuel. See, this network was an absolute monster. It had 60 million parameters. You can think of those as 60 million little knobs that the AI has to tune just right to get the answers correct. A regular computer processor would just choke on that. So the team had a brilliant idea. They used 2 powerful graphics cards, yeah, the kind for video games, and ran them at the same time. That raw horsepower was the only thing that could handle a model this massive. And superpower number 3 was this really clever anti-cheating trick called dropout. Here's the problem. When a network is this powerful, it can get lazy. Instead of actually learning what a cat looks like, it might just memorize the exact pictures of cats you showed it. Dropout stops that. While it's training, it randomly just turns off parts of the network. This forces the other parts to pick up the slack, making sure the whole network actually learns the features instead of just memorizing. It's kind of like if you were studying for a test, but you didn't know which chapters would be on it. You'd have to learn everything just to be safe. So there you have it. ImageNet had its turbo button, its rocket fuel, and its anti-cheating system all in place. They let it train for almost a week straight on all those images. And then it was time for the big reveal. How did this new contender actually do in the AI Olympics? Well, the results were, honestly, they were shocking. The second place winner, which was using all the best techniques from before this, had an error rate of 26.2%. So it was wrong more than 1 out of every 4 times. And ImageNet, its error rate was just 15.3%. I mean, just look at that difference. This wasn't just winning. This was a total takedown of every other approach. Let's just pause on that for a second. That's a jump of over 10 percentage points. You have to get this. In this field, people would fight for years just to get a 0.5% improvement. This was unheard of. It wasn't just a step forward, it was a giant leap into a completely new era. The entire field of AI changed direction, like the next day. So this win, it was so much more than just a trophy. This was the moment that people now call the Big Bang of modern AI. It was the first time the world got a real undeniable glimpse of what this deep learning thing could really do. And what was so cool is that we could finally peek under the hood and see how it was thinking. What you're looking at right here are the actual simple patterns that the very first layer of ImageNet taught itself to recognize. It's not looking for cats or dogs yet. It's learning to see the most basic things in the world. Edges, simple colors, different textures. These are like the Lego bricks of its vision. And this is where the real magic happens. When ImageNet sees a new picture like this one of a Dalmatian, it's not just checking boxes. It's actually matching that picture to the concepts it learned. See these other images it thinks are a match? They're not identical copies at all. The lighting is different, the angles are different, but they all share the same dogness. The AI didn't just memorize photos, it learned the idea of what a Dalmatian is. So this wasn't just a win in a competition, it was proof. It was the moment that showed the world if you get a massive amount of data, throw a ton of computing power at it, and use one of these deep neural networks, you can solve problems that seemed impossible just a year earlier. This one result, it's the direct ancestor of the AI we have today. From ChatGPT to self-driving cars, it all started right here. So in a nutshell, that's the story. In 2012, a single paper gave computers the gift of sight. It solved a problem that brilliant minds had been stuck on for decades, and in doing so, it kicked off the revolution we're all a part of now. Which, of course, leaves us with one heck of a question. In 2012, AI learned to see. What will it learn next?